In this video, I'm on page 63 and we're going to be looking at tree diagrams. And I've written out the prompt, the question, if you will, that we are going to address. And if you need to pause the video and copy this, by all means do so. We want to show the possible outcomes of tossing a coin 3 times. So let me just draw you an example of the coin. It could be any coin, a penny, a quarter, a nickel, a dime, a $50, a Canadian dollar, whatever. It could be any coin. But you're going to have one side that has a face on it. That's the head side. And then depending on the coin, you have the another image on the back. So you have heads or tails. And those are the only 2 outcomes you can get for tossing a coin. So let's do a tree diagram. So I take a coin and I flip it and it lands on the table. It will either be heads or tails. It's the only option that it could be. All right, I flip that coin again. So let's say that on the first flip, we got heads. On the second flip, you could get heads again, or you could get tails. So the first flip was heads, second flip will be heads or tails. If the first flip were tails, you could get, on the second flip, heads or tails. So this is the first time I flip the coin. This is the second time I flip the coin. And we need to do it a third time. So I'm going to go heads or tails, heads or tails, heads or tails, heads or tails. So let me put those in there. And then I'll show you how to read this diagram. This is, for me, it was the tricky part. So here is the third flipping of the coin, right here. But these are dependent on what you got the first 2 times. So this will be the 3 sets of flips. And let me color code. Let's try it that way to see if that helps. So this was the first time I flipped the coin. This was the second time. And only one of these would turn up. These are just the different possibilities that could turn up. Okay, so let's come through here and set up these possibilities. So on the first flip, we had heads. Second flip, heads. And third flip, heads. So I'm doing this row of the diagram. Heads, heads, heads. Okay, this one is going to be heads, heads, tails, HHT. Then we have HTH. And then we have HTT. Heads, tails, tails. Okay, so this is the first possibility, assuming that the first flip was heads. All right, down here we have tails, heads, heads. That's a possibility. And then we have tails, heads, tails. That's the next branch of the tree. And then we have tails, tails, heads. That's the next branch of the tree. And finally, we have tails, tails, tails. So all 3 flips were tails. And these are the different possibilities, the different combinations for tossing a coin 3 times. These are the different outcomes of that experiment. There are 8 different results. Another way that you can express those results, let me just bring this over a little bit if I can, and that is to draw a table. You know that I like tables because tables help me to organize information, especially this kind of information where there's a lot of it and it all looks alike and it's all just kind of jumbled up together. So we're going to make 3 columns in this table for the 3 tosses of the coin or flips of the coin. So this is the first toss. This is the second toss. And this is the third toss. So this is the experimental design. This is the way that I set up the experiment. So this one, HHH, tells me that we got a result of heads on all 3 tosses. Then we could have heads on the first, heads on the second, tails on the last. We could have heads, tails, heads, heads, tails, tails. And I'm running out of space, so let me go ahead and take out this bottom row here. And we'll put in 2 more rows. To make enough room. And then we get tails, then heads, tails, heads, tails, 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 heads, and tails, tails, tails. So the tree diagram and the table are showing the same information. The first toss I highlighted in blue. The second toss I highlighted in yellow. And the third toss I highlighted in pink. And the different outcomes are these. So there are 8 possible outcomes. And we can see that with the tree diagram or we can see it with the table. Either way is saying the same thing. And in case you want to print this, let me make this just a little bit larger so you can really read what I've done there. Okay, let's take a look at the meaning of a factorial. And this one is a little bit weird looking, but it's you can do these on your calculator. I want you to see, first of all, what the practical meaning is of a factorial. So here's the example they give in the book. I'm just going to read you the story. Suppose you wanted to organize your music collection. How many ways could you list your songs? If you have a large collection of music, this number is also very large. But how would you determine it? Let's look at the problem on a smaller scale. If you wanted to organize, let's say, 4 songs, and here's the table that they give me. So here is the music collection that we are going to take a look at. We have song A, song B, and song C. Oh, sorry, and song D. We have 4 of them. So I'm going to put these in a playlist. Let's say that these are on YouTube and I'm building a playlist of my music. And so I have to decide which song goes first. Now we have 4 songs, so I'm going to make 4 columns here. And I'm going to just go ahead and divide this off. So in my playlist, we're going to have to decide which song to put first. Your favorite, probably. Then the second song. The third song. And then the fourth song. So I could take song A here, and I could put it in this slot, this slot, this slot, or this slot. So I have 4 different choices for this first slot. I could put any of those songs in the first slot. So in this particular one, we have 4 choices or options. So let's say that I put song A in that first slot. So I'm going to take song A out of here and put it in that first slot. So how many choices do I have for the second song? I only have 3 choices. And let's say that I choose B, that I'm just going to put B in that second slot, so I take it out of here, put it in there in my playlist. For the third song, I only have 2 choices. Okay, so let's say we use C, so we take it out of here, put it in the playlist, and for the fourth song, I will only have 1 choice. And it doesn't matter which one I put in for the first choice, I still will just have the 1 choice when I get to this point in the playlist. So it's going to come out of here and go into the playlist. Okay, so here is the definition of a factorial. I'm going to give you the math definition, and then I'm going to use this to show you what it means. Here's the math definition. A factorial is the product, so we're multiplying, of a series of all descending consecutive positive integers. Now don't panic on me. We're going to see how this all fits together from a given starting point. If you need to stop the video to write down this definition, that's fine. Take all the time you need. Okay, and then I want to study this definition. Let's decipher this definition. So we have the word product, that means multiply. Descending means going down. Consecutive means you're not skipping any. Positive integers means you cannot have negative numbers. And a given starting point just depends on the story that you're working with. So let's apply this here. We're going to take these numbers right here. So we have 4 choices. Then we have 3 choices. Then we have 2 choices. And then we have 1 choice. So we have descending. They're going down. Consecutive. 4, 3, 2, 1. We're not skipping any. They're all positive integers. And we need to do what kind of math? Multiply. This is what factorial means, literally. So you would say 4 times 3 is 12. and 12 times 2 is 24, and 24 times 1 is 24. So we would say that 4, that's the starting point, 4 factorial is 24. That's how you would read what I just did. 4 factorial is 24. And this continues over onto the next page where it talks about factorial. I'm not going to read all that, but I am going to show you what it says because I need you to understand the symbols that go with this. So this is how you say it. 4 factorial is 24. Mathematically, if you're writing it as a math problem, it will look like this. 4 with an exclamation point. That says 4 factorial. Now, to do this on the calculator, you will say, oh, I don't have a button. I thought I still had a square, so let me draw one. These are the buttons on the calculator that you will need to use to do this problem. So we're going to say all clear, 4, shift, and I can't remember the next button, so I'll put a space. I'll have to look for it. And then equals. So you need 6 keystrokes to do this. The first one is all clear. Clear the calculator's mind before you start. So all clear, 4, shift, so we can get to the second functions, and it's over the number 3, shift 3. And I didn't need all that. You don't even have to hit equals on this one. But I encourage you to, because that's a very good habit to be in. And you see that the answer is 24. So 4 factorial equals 24. And I'm going to go ahead and stop this video, and we'll pick up on page 64.